Hello, I am Rohit Naik from 3rd year BTech Electronics and Telecommunication Department. Our group presenting the ISC for Digital Signal Processing. For this, our topic is MATLAB code for adaptive filter using the mean square error. My group members are Tanmay, Tejas, Shreyash and me. Tanmay and Shreyash will explain the MATLAB code and Tejas will explain the output figure of the MATLAB code. Now I am going to explain what is adaptive filter. An adaptive filter is a digital filter that has self-adjusting characteristics. It is capable of adjusting its finite coefficients automatically to adapt the input signal via an adaptive algorithm. And now we see this simple block diagram of adaptive filter. Here we giving the input signal x of n. Our signal process into unknown system and gives output d of n, and output of adaptive filter is d cap of n. Adder adds these two signals, then the difference between d of n and d cap of n is called the estimated error between the filtered signal and desired signal, and it also shows mean square error. In signal processing, two parameters are very important. Signal to noise ratio is maximum and second is mean square error, it should be minimum. Adaptive filter generally tries to achieve the error is zero, so we achieve the optimum signal. Adaptive filter plays an important role in modern digital signal processing products in areas such as telephone echo cancellation, noise cancellation, active noise control, and adaptive control system. Now the next part will be explained by Shreyash.
Thank you, Rohit, for explaining the first part of the code. So, myself Sresh, I will explaining the code. We will see the MATLAB code is adaptive filter using the mean square error. Let we will see the following task of this code. First of all, initialization. Then define initialization global variable, conversion factor, filter length, number of iteration, input white noise, initial input, initial coefficient. Let then calculate first iteration. Uh, in this iteration, calculate error signal as the difference between desired signal and filter output. Calculate mean square error uh, as the square of error signal. Update the coefficient using formula. Uh, Update the coefficient using this formula. W is equal to W plus mu into E into x dash. Then calculate nth iteration. For each iteration, the code delay of the input signal x. Update the input signal of input sample, new sample. Uh, then calculate output of adaptive filter and error signal, and then calculate mean square error uh, and mean square error as a square of error signal. Update the filter coefficient using this formula. Then we will see using this formula, W is equal to W plus mu. uh, that was from my side. uh, Further part will be explained by Tanmay.
Thank you, Shreyas, for explaining the first part of the code. So, myself, Tanmay, I will be explaining you the next part of the code. So, here, as you could see, two figures on the right side, which are magnitude versus frequency plot and phase versus frequency plot. So, for this part of the code is written in this block. Just a minute, I will highlight. So the highlighted part will give you these two plots, which is magnitude versus frequency and phase versus frequency. Then hold on, what hold on actually does, it holds the current plot, and if you add the next plot also, the first plot remains intact. Then we have function h comma f. What is actually does, it returns the frequency response of n samples. Then we have subplot 2 comma 1 comma 1. Actually the first element of the subplot, which is 2, which will give the number of rows, then 1 will give the number of columns, and then 1 will decide the position, like in which quadrant the plot will be there. Then we have x label and y label, which are used to give name to the x-axis and y-axis respectively. Then we have same for the phase versus frequency plot. Here it is a plot 2 comma 1 comma 2 and x label and y label. Then we need to calculate mean square error for each iteration. So now we will go to the figure number 2. Here you could see it is MSE versus iterations. So for this we need to write this part of the code. So here the logic num is equals to 0 is to length, MSE minus 1 is used. Then for plotting this graph we have written here hold on and grid on. Actually I have explained hold on earlier. Then y label and x label for giving, as you could see on y axis it is MSE and x axis it is iteration. For this we have used x label and y label, and for plotting the graph we have used the num, MSE and v. So now we have used our function display for estimated coefficient w is equals to for displaying the values of w in the command window. As you could see it down here, I will highlight. So for getting these values we have written this function w, and for displaying final error and estimated coefficients we have written this function which are here below in the command window. Then we have function down. The function is called here actually, and its definition is down here. This block, what it will do, it will convolve the input signal with system of coefficients. It will and give us the output. So it is basically a convolution. Then here we have written uv, which are system of coefficients. We have given provided system of coefficients, then length of system, then new sample, and lastly we have written end. Actually end is written to make the code readable, but also it is used to end any function. So we have written a function and we have written end to end it. So that was from my side. For the next part I would hand over it to Tejas. Thank you.
Hello everyone, I hope you are doing good. Now, as we have gone through the code, now we will see the plots that we have generated through the code. So these are the responses of the filter. The first one is the magnitude response, second one is the phase response, and the third diagram is of the mean square error versus the iteration. So in the first figure, the x-axis is the frequency and the y-axis are phase and magnitude. These are the number of phase changes that took place in this one iteration. Now we will look at the mean square error versus the iteration graph. So as you can see, the number of iterations are increased and the mean square error is decreased. So we can imply from that mean square error decreases with the number of iteration increasing. So this is the all. Thank you for listening to our presentation.